Mic is on, and this is me. Welcome, everybody. I'll just give a few seconds to check that everything is running smoothly and then the audio is streaming correctly. But welcome to my living room. My name is Felipe. I'm a creative director in MakerBot, and I'll be talking today about how I set up my MakerBot method here. Now, with the current circumstances, we know that many designers, many engineers are facing increasingly working from home, remotely. But the idea here is to do a quick rundown of how do you set up the printer regardless of where, specifically focusing on the amount of space needed, kind of the unboxing experience, the requirements. But I'll wait a few seconds just to make sure that everybody's here. Give a few more minutes for people to join. And in the meantime, I will also like to introduce Allison. Allison is going to be the behind the scenes producer. Basically, she's the little voice in my head talking to me through this earpiece, letting me know if the audio is okay. If you guys have any questions, please make sure to ask questions on the chat window right there on YouTube. There's a nice chat feature on the left side of the screen. And I'll try to address those questions as we go. Other questions I'll wait till the end. We'll have a Q&A session at the very end. But yeah, let's give it a few more minutes, maybe one more minute, just to make sure everything's running smoothly. All right, cool. So welcome. Good morning. As I said before, my name is Felipe. I'll be giving you today's webinar on how to set up your method, basically your work from home studio. It's basically my setup, but the idea is, restating a little bit. How do you set up a method? What are the space requirements? What's the unboxing experience? As we all are trying to struggle with the fact that we have to work from home, and it's kind of hard, right, to figure out like, okay, when would I need a 3D printer at my place? How do I put it? Even if I have a smaller studio, right? Even if it's not about working from home, but I want to know how do I set it up? How much space is required? So all of those questions are the things that we're trying to cover today. A little bit more about myself. I know I'd like to talk about myself a little bit, it seems like. But I'm an industrial designer by training. I've been doing that for about a little bit over 10 years. I'm New York City based, and I'm currently the creative director at MakerBot, which allows me to get a lot of quality time with these guys, printing a lot, using them a lot, and experiencing how is it to. Oh, the URL is showing. Yeah, well, if you guys get access, I know that I cannot hide the URL tab, but bear with me with that. So, creative director at MakerBot, getting a lot of quality time with the printers because of that, and I like bikes. That's important. I like bikes a lot. Getting into it, right? So, what are going to be the main requirements, like diving straight into the idea of, hey, I want to set up a printer, I want to get it at my place, what should I be considering, what are the minimum spatial configurations that I will need to keep in mind, and how tricky is it going to be, right? Overall, I would say you need a work area of a little bit over 10 square foot. The printer itself, sorry, there's a typo right there, it's not the print but the printer itself, the base of it, it's about 17 inches square. So it's relatively medium size. You have to think about also the power requirements. Do you have an area that's close by to an outlet? Specifically, in this case, I set up a Method X. We have two different models of the Method and Method X. They have different qualities and capacities, and because of that, they have different power consumption. So right there, I'm stating, in Method's case, they both work either at 100 or 240 volt system, but the amps, the max current is going to change quite a bit, almost twice as much in the Method X versus the Method. So you do have to consider that the outlet that you will be plugging this printer will need to be something that's used to or can withstand a larger output. Basically 800 watts maximum for Method and 400 for Method X and 400 for Method. The easy, rule of thumb that I used here was where I plugged my AC unit. It's kind of close to that. It's not always going to be running at that high consumption. It's mostly when it's heating up. The reason behind the difference is because these printers have a heated chamber, right? And the heated chamber actually enables you to print with higher quality enables you to print with different materials, some materials that are fairly sensitive to temperature changes, and the whole printer is enclosed. So as the printer is heating up, you have to think about it as a kind of an oven, right? A kind of a microwave running and getting ready to get that temperature on the right place, and make sure because of that that the material is going to behave nicely and smoothly and according to what you would expect. So in my case, I picked this little corner area of my apartment. It's close to a window. In most cases with open chamber 3D printers, you don't really want to be close by a window because drafts or breezes can actually compromise your print quality, your print accuracy. In this case, since the printer is enclosed, the printer is self-heating itself, the whole printing environment is highly controlled. You don't really have to think about or worry about it as much. In my case, it was more like, well, it's kind of an open corner. It also had already this piece of furniture that I had used just to put up my laptop. And it was kind of roughly the same dimensions or enough for me to place the printer, right? Those 17 inches square. Now, give me a second. Here we go. Second thing to consider, right? The actual shipment of the printer. So how big is the printer? Not only the printer, but how big is going to be the box and the work area where you will be unboxing said box. So in my case, I basically staged 4x4 work area, right? You can see, in that photo over there, it's basically a corner of my living room, and I placed the box there. The box is noticeably bigger than the printer itself because of the padding and the cushioning that comes with the printer. It's about 22 square inches in the base and about 31 inches high. You will have to consider some delivery constraints. Specifically, more often than not, you will have to have an appointment set up, whether you're using UPS, FedEx, or any service delivery. You'll probably have to be here. It's an expensive piece of equipment, so you want to make sure that you are here to receive it. Not only because of that, but also you'll probably be super excited to be getting it, right? Eager to start playing with it. Thinking about the entryway, staircases, elevator here in New York, right? It's kind of always have to think about whether you have an elevator, you have a staircases to walk over. In many other places, I know that might not be the case, but you still want to consider, where are they going to put down the printer? How do you get it to that box to the final place where you will be setting it up? And once you have that space cleared up, as you see in that photo, then you can appropriately nest the box. I think 4 feet square sort of did it for me. You don't need that much space. You'll see why in a second. Actually, the box itself or the unboxing process is fairly streamlined. I really appreciate the effort that was taken there. And also, you will have to plan for the printer's weight, right? This guy is not your average desktop little printer that, thinking about the Rep Plus or some other more basic printers. This guy is heavy, right? It's about 65 pounds, about 30 kilos. So you will want to make sure that this surface is sturdy, right? Can withstand that weight. Once you have covered that, let's see. All right. Step one, just unboxing the printer itself, right? Fairly straightforward, especially because, as you can see in that picture, the box itself sort of slides out of the printer. So it has 4 clips on the sides, on each side. You just remove those clips, and it's really easy to just slide that box up and away from the printer. So you can just put it to the side. It's super convenient because you get rid of, I would say, 70% of the boxing elements altogether at that point. You just remove the box cover, remove the side covers, the protection covers of the printer. You can see on the picture there to the left, lower left corner, that is going to be this piece right here that comes separate from the printer in the same box, but it's kind of the first piece. Let me state here. The first piece that you will get out of the box, right, which is the top lid cover. This top lid is basically there to control the chamber temperature, control some of the settings, and it's just a clear piece of plastic that will nest on the top of your printer. That's going to be kind of like the last step, so I'll get to that in a minute. But yeah, you clear your space, you have that work surface already open, you start to see in that photo how inside of the printer there's a customer kit, right? There's a box inside of the printing chamber. I'll get to that box in a minute. But that's kind of the step two. So once you remove the box, you remove those safety clips, you unlock that cover, then you rebuild the main printer, and the printer will come wrapped in that plastic. The plastic is there just to prevent any scarring or damaging through shipment. You remove that plastic, and then you get to the fun part. The fun part being just lifting up that printer and setting it for the first time on the work surface, right? In this case, it's it's a wood piece of furniture. I'm sure that many of you guys might be familiar with it. It's basically straight from IKEA. It's fairly sturdy. Just the minimum requirement is it has to be a flat surface. You want to make sure that it's not wobbly at all, because the printer will be moving quite a bit as it prints, so it needs a steady surface. The printer won't shake. The printer itself is built with it's what we called like an internal skeleton, right? A very rigid structure that doesn't allow it to flex in any way as it's printing. However, if it's placed on top of a wobbly surface, that surface can really shake quite a bit if you let it, right? So you want to consider that before placing the printer in the final surface. There's also lateral handles in the printer. So on the sides of the printer, you will have two big handles that allow you to lift it up from that base and place it on the final surface. I would recommend using at least two people to set it up. It's as I said, it can be heavy. You can do it on your own, but it's highly recommended that you use two people. Just make sure that you put it in place. Kudos to my wife. She had helped me lift it up just to make sure you want to be careful with it. You don't want to risk dropping it or even damaging some of your furniture. So just to be safe, use two people, put it in the work surface, and get over with it. And now getting to the customer kit, right? What is the customer kit? And I actually have both that photo. Let me put it here. That photo and the kit itself with me right here. So the kit comes inside of the printer. It's super useful because it will guide you through all of the additional, it's got both accessories and elements that you will need to get started with printing. Specifically, what I mean by that, and I'll do a quick rundown on what those elements are. The first one that you will get is a flexible build plate, right? The flexible build plate is going to be your printing surface. It's a spring steel build plate. It has a plastic wraparound, and it's very flexible, right? You can see how much I can bend it, and it'll snap straight back up into place. The idea here was, when we first were designing the printer, was to be able to easily remove the parts after you've printed them. So once you've completed the print, you just flex the build plate. You can flex it quite dramatically, as you can see here, and it'll just go back to its flat state, because the spring steel is basically kind of a memory material, right? You want to go back to its flat state. This build plate, of course, goes inside of the chamber, right? So you will just nest it there. It's attached to the chamber via magnets. They are fairly powerful magnets. Let me just do a quick demo of like how you can hear how it's snapping back into place, right? The magnets are just pulling that build plate in. But anyways, that's item number one. Item number two is going to be, of course, a replace grip surface for the build plate. So that's basically the base element that covers the steel itself. That's going to allow you to have additional grip for as you're printing or for your printed parts. You will also get super important, two extruders. Depending on which model you're getting, you can get extruders 2x, 1x and 2x, or if you're getting the regular method, you will be getting extruder 1 and extruder 2. Why we have two extruders? We have two extruders because those are going to be used for either the model material, so the material that your parts are going to be made out of, and the support material, right? So the material that's going to act as support in case you need it for certain parts, right? You get two of them with the printer. In this case, as I said, it's Method X, and you can see how this thing I love. It's just like a really complex piece of engineering. I remember having my first extruder in a regular replicator, the original replicator, way back when, and it's evolved quite a bit, right? So these guys themselves are worth a quick chat I won't do it right now, but if you have any questions, there's a lot to be talked about this, whether it be how much longer the heating element has become, the gearbox that they have inside just to make sure that the filament is running smoothly, the smarts on them just to detect that whether or not there's any issues with the printing process. But we can talk about that in a separate occasion. Another important element that you will be getting with your customer kit is just a humble metal brush. The importance of this guy is going to be specifically for calibration, right? After you print it a few times with your extruders, and I actually have with these, maybe you can see this on the video. I'm not sure if you can see it, but it's a little bit darkened, right? The reason for that is that the plastic, as it melts, it leaves a little bit of debris on the nozzle. This guy, the brush itself, is going to allow you to clean. Oh, maybe let's do this. I'll show you the nozzle before cleaning it, so it's kind of like dirty and darkened. And after cleaning it, you will get rid of most of that plastic debris. This is not going to be super annoying. Oh wow, super effective. You see how clean it is now? There you go. Shiny, almost like brand new. So this debris is not going to get much in your way as you're printing. The thing that you want to consider is it's more for calibration purposes. The reason being is Method is a completely automated machine, so you don't have to run any weird calibration you know, games where you have to put this paper card in the printer and then see if it actually drags or not, and then evaluate how much offset do you need on the print head. Instead, what happens with Method is that when you run the calibration, the printer will do it on its own, and it'll actually gauge the exact position of the nozzle by checking on the offset. It's going to be hard for me to show this, but the offset of the actual nozzle and that flat element of the nozzle. So it's basically probing against a stainless steel component here, basically a target, and it'll be probing against that target several times just to make sure that it knows where exactly in space the nozzle is, and it'll do that for both extruders. So that's the importance of the little brush, so that you can clean your nozzles before calibrating it. Specifically, you probably won't have to do it when you first unbox the printer because the nozzles are completely clean. But after a few times, maybe when you switch around extruders, and we'll talk about it in a bit, you will want to do that, and you will want to recalibrate, and because of that, clean the extruders before you calibrate. Another really useful item that comes with the printer, nozzles, pliers, super useful in removing some delicate supports elements. A spatula, it's great. So it's not only, you're not only able to flex the build plate, to remove the printed part, you're also able to just help yourself with the spatula. The spatula comes in handy. Personally, I like to get as much of the parts just by flexing the build plate. The reason for that is, well, it's the more you use a spatula, the more you can damage the grip surface. That's why we include two grip surfaces, and you can get additional replacements of this, so you don't have to change the whole metallic part when you want to replace the grip surface. However, I would say 80% of the time I just pop the parts right out of the build plate. It makes it way easier. And of course, the power cord, right? The power cord, Method ships with two power cords, one for Europe, one for the US, and others. So depending on where you are, you decide which power cord you need to use, and require adapter. Moving on. So this is where the fun begins, right? Once you have everything sort of already in place, let's say that you've already finished the starter kit elements. You can see in that photo how I got the build plate on top of the printer. There's a reason for that. But you will turn on your printer for the very first time, right? The first thing that you will notice or be prompted to do is name your printer. That's, I don't know, maybe it's just for nerds, but it's super exciting of the process, right? Basically, how are you going to be naming your machine? In this case, I went a little bit boring. I named it XBot. But anyways, you can name it whatever you want. The reason for that, is because you will want to connect later through either our slicing software, so you will want to easily identify which printer you're referring to. After you've named your printer, you will set up the Wi-Fi. The Wi-Fi will in turn enable you to download the firmware updates. So super important, right? We constantly release new firmware updates for the printer, and this it's just mind blowing how much it adds capabilities to the printer, right? As our engineers fine tune the elements, the sensors, the different available extruders, the different available materials, that those firmware updates almost feel like getting a new printer all the time, because now you have a printer that can print with a new material, or now you have a printer that can print at a higher temperature, which is just incredible, right? To see how that sort of uh, tool evolves, right? It's not like a lathe, it's not like a drill that just it's a drill and that's it. In this case, it can keep adding features to itself, and that's always super exciting. You will also be asked to verify your account. That means creating an account in MakerBot.com. The reason for that is that that account will allow you to connect to the printer via our web services. That allows you to slice files remotely in the cloud, sort of streamlines the process of 3D printing. You don't have to do that. You can skip it. We've heard about a lot of our customers, especially in the professional sectors, maybe in defense, maybe in some sectors that are highly sensitive to connecting the printer to web services. You don't have to do that. That's just an option, but it really adds another layer of accessibility to the printer. If you don't do that, and also this is also true for firmware, you can download the firmware via USB sticks. In this case, I have a trusted USB stick. That's also completely fine. You can download the latest firmware, go to MakerBot.com, find the latest firmware, download it to a USB stick, plug it into the machine, and keep running. It's one or the other. You're not locked in either one of the scenarios. The next step is what I was describing before. It's the calibration. And I want to, let's see, how are we doing in time, right? So it's okay, I think. I want to just run a little bit of a section of the calibration process, just so that you guys see what I meant, right? Because you can calibrate at any time the printer, right? If you feel like there's something weird, to be honest, I've never seen it happen. But it's more often when you change extruders. The extruders are, this. I showed you the extruders before. They are nested in here. I have a picture of that in a second. But basically, if you were to change extruders and you wanted to use a new one, the printer itself will recommend you to recalibrate, because you will want to know, like, okay, what's the actual offset of this new extruder? Something might have changed. Maybe you placed the extruder just a little bit off. And because of the tolerances and the precision that this machine uses, you really want to make sure that those extruders are just like, in spec. I'll switch over here to my view, and I'll just do a quick rundown of the calibration routine. So, sorry. You go to the settings option, and under settings, you'll see an option to calibrate extruders. Also, by the way, you see like the super smooth touchscreen. It's kind of a great interface also. You will need to have the lid cover placed, just because it wants to make sure that you're not sticking your fingers into it when you're calibrating. Hit begin calibration. Oh, there we go. Close the lid. I'll try to talk a little bit on top of it. I won't let it run the whole calibration sequence. The calibration sequence is about maybe 5 to 10 minutes. It's not that long, but it's just like, describing a little bit of what it does. Step 1, make sure that the build plate is raised up properly. Step 2, it'll ask me to remove the build plate. In this case, I already have removed the build plate, so there's no build plate in the printer right now. Once you confirm that, it'll go back to that question that we were saying before, right? I'll just move my computer here. I didn't want to do that, but so it'll ask you to clean the extruders. In this case, I'm skipping it just because this is just for you guys to see real quick what happens. And after that, you can see the extruders going back and forth, looking for that target. You see that shiny target right there? They are going to be probing against that target over and over again, just to try to ensure that they know, well, not trying, but actually knowing. I'll cancel the calibration. Stop calibration. All right. So they will be probing that target to make sure that they know where in space the specific point of the nozzle, like the final point of the nozzle is. And the importance of that is kind of self-explanatory. It's because you really want to make sure where you're depositing the material, right? You really want to make sure that the printer will know where it's printing, basically. After the calibration, let's go over here, switching over to the deck again. After the calibration, the other really interesting action that will happen is going to be the first material loading process. As you know, and you can see that in the photo right there, but I'll show it here a little bit too. Method comes with two material bays, and these bays are enclosed. I'll talk about this guy in a second, right? I'm sure that some of you have noticed that I have a spool loaded to the side. There's a nice feature to talk about that too. But anyways, the main system that will drive your materials into the printer are these two material bays. It's basically two dry seal drawers, and inside of those drawers, you will place your MakerBot material, right? The material itself, it's similar to the average kind of just wounded spool. However, it does have a chip inside, and I'll talk about this chip just for a second because I really like this one. It's hard to get it out, but probably I won't be able to. But the cool thing about the chip is that it actually has an RFID chip that allows the printer to know which material you have loaded, and not only that, but how much material you have left. The cool thing about that is that before you start a print, you know how much material you have left, whether or not it's going to last enough for you to finish the print, and it will give you a warning like, hey, the material might not be enough for you to finish the print. Would you like to change it, or would you just like to start? And whenever I'm out of material, I'll let you know. So you can choose one or the other. But yeah, the material loading is basically that. You put either material on the build plate. The material comes in this really snazzy bags, kind of, we call them space bags. Basically, it's a mylar bag with a Ziploc. The reason for the Ziploc is, of course, you want to be able to repackage the material in case that you're not using it. Right now, that's the case for me when I'm using multiple materials. I've been playing with the printer quite a bit. So the material comes in the mylar bag, just out of the bag, and then it's pretty straightforward. The bag is it's also super clean. Great job by the design team and Joe Vishnu, our designers, did a terrific job at creating this. So you load. Oh, humidity, right? Sorry, my little voice in my head asking about humidity. Cool. So two big reasons why you want to use the material base. Many of these materials are going to be super sensitive to humidity, especially PVA. PVA is a standard support material that we use for our method printer. That's a water-soluble material, and because it's water-soluble, it's super sensitive to any sort of humidity in the environment. Right? If you were to leave that PVA outside of the bag or outside of the drawer, then that material is going to start absorbing moisture from the environment and degrade slowly. As it degrades, you won't really see anything noticeable on the material itself. But when you're printing, you'll start to hear this sort of hissing or popping sound. We've seen a lot of people hacking solutions out there, whether it be by putting a plastic box where kind of a Tupperware where they keep that material inside and then just route the filament out from it. In Method's case, that's actually done. There's many other printers that sort of claim to have this professional setup, but they still have those materials exposed. So, it's not the best. Some materials are able to tolerate humidity fairly fine, but for PVA, for SR30, for nylon, they will start degrading in time as they get exposed to environmental humidity. And especially, considering that I'm here in an apartment, then it's not as controlled as a factory floor, right? It's not as well ventilated as a factory floor. Maybe it should be a little bit more. I'll open the window later today. No, but it's really important, right? I'll get to the side mount in a second, but that side mount it's a new option that we've opened for Method, so that we are also able to open the platform for additional materials. I'll talk a little bit about that in a second. But ideally, you want to keep your materials here, except for the ones that don't really have that much sensitivity and can be side loaded into the printer. Going back to the deck, the first print, which in my case was this, it's a customer part actually. It's a fan from a company that we've worked a lot with in the past called All Axis. This is a chip fan. It basically blows the chips after the CNC is done. There's a routine where the CNC will clean itself. This is a rather expensive piece of equipment if you were to buy it right off the shelf for the CNC. But in this case, we were able to print this guy with for them. In my case, for the first print, I just printed it in ABS with SR30 soluble supports. So that white material that you see in the photo is the SR30 that gets removed or dissolved once the print is complete. Um, and what your first print is going to do is going to check for correct layer alignment, right? Just to make sure that everything is sort of calibrated appropriately, that the printer is behaving as you would expect. I would say, the first run of the printer actually comes with a default print example that's super simple. It's basically a square that allows you to know in 10 minutes whether or not the calibration has been done or has been achieved correctly. But I also like to just test with a more complex part. In this case, this one took about 13 hours to print. So just did a quick overnight, just to make sure that everything is where it needs to be, right? And also, at this point is where you can start testing with different materials, right? Kind of exploring what are the options that you have. In my case, since I have the method X here, I have a little bit of wider breadth of materials, which is great. So I can print ABS as this guy. I can print SR30. I can print with regular PLA. I can print with our tough filament. I can print with nylon. So just, getting a feel for what the materials capabilities are. And once you start playing with the materials, it's just mind blowing how far you can get, right? So I have a few examples here. Let me go back to my webcam view. I've been having a blast with the printer in the past couple of weeks, which I guess is good given the fact that I'm spending a lot of time indoors. But I've been printing a lot of different parts, whether that be from a customer. So in this case, another part that's basically a mount for a gripper on a robot. Right? I've been printing with other materials. One of the most exciting ones, and it's the one that's side-loaded, and I'll talk about that one specifically, is this flexible material, right? So this one was printed about a week ago here on this machine, and it's the material that I got side-loaded. The reason why this material is side-loaded is that we recently introduced a new extruder, which is our Labs extruder. You can see here. Let me get some light to it. Yeah. Our Labs extruder, which basically opens up a lot more possibilities for you to use. So you are not necessarily just playing with the materials that MakerBot supplies, but now you can use third-party materials. In this case, this SEBS material, it comes from Jabil, and really start pushing the boundaries of what the printer can do, right? So these flexible materials, I printed just a very standard pipe. It's super nice and super squeezy. And then just, don't tell anybody, but I've been also playing with, just doing some sort of maybe passion project, I don't know. But it's just trying a wheel, right? In this case, it's got 0% infill, so you can see how flexible it is. Let's see. Here we go. Right, so it flexes quite a bit. It's really a nice material. So this is with 0%, not with no infill, and this is with 20% infill. So it's a little bit, here we go, a little bit stronger, right? It's harder for me to press on it. But yeah, the flexible material. Sorry, what's that? I got another comment. The flexible filament. Oh, the name. Sorry, the name of the flexible filament is SEBS, SEBS by Jabil. Jabil is Jabil. It's great, right? I really love it. And the point here is that this machine is a freaking beast, right? Once you start playing with all of the different material options, it's just too exciting. I can talk about them, for hours and hours, but I'll have to do that some other time. So, as I'm saying, with the amount of extruders, in my case, I also got not only the extruders that came with the printer, but a set of extruder 1 and extruder 2. Those are the extruders that regularly come with the standard method. So we have two models, right? The method and the method X. The main difference between the two of them is that the method X can get, the chamber itself can get hotter, and that expands the number of, or the available materials that you can use, right? Because some materials really, really need higher temperature in order to be able to be printed. So I got both sets of extruders, the extruders for the method and the method X. And that's the great thing about the method X specifically, right? You get all of the capabilities of the method X plus the capabilities of the regular method, right? So you just add the extruders and you got basically a second machine almost. So it's kind of really nice to be able to grow with the printer and extend that range of materials that you might have. Doing a quick overview, I'll run this time lapse. So overall, and you can see the clock to the right of that video. I'll just run the video, but it was about 45 minutes from unboxing to print time. So you see it's marking when it starts. Oh, that's finishing. So I'll just let it run. You guys can see it. Unboxing, getting the printer on that surface, starting the firmware download, calibration process, and that was it, right? It's fairly fast. I know that it's of course time lapse and super sped up, but I'll run it one more time just to see what. So it starts at 4:20. Uh, not me. That's happened to be at that time. And by five it's pretty much done, right? So it's about a 40-minute process. I wasn't around for the whole of it, specifically when it started downloading the firmware. I went and got a coffee. When it started doing the calibration, the same thing. I don't have to be around the printer. Even with the calibration process, it's not like other machines where you have to actually, once the calibration print is done, you have to sort of measure it and see if it's, what's the appropriate offset. This printer just knows. It's amazing in that. The 4x4 feet area required. I think that's a good rule of thumb. It's very, doesn't need a lot of space actually for you to manage it. Considering ventilation and sound, in this case, because it's in an apartment, because we are in New York City, it's tight. So it's tight, and that basically means that you can hear it quite easily, right? So you want to put it in a separate room. You want to make sure that you're not able to hear it at night, especially if you're thinking about printing overnight, as I think we all are. It's like sometimes it can drive my wife a little bit crazy to keep hearing the printer overnight. But anyways, consider that. Consider when are you going to be printing. It can make some sounds, as you heard with the calibration. It's like kind of like this high techno sounds. I like them over the day, but overnight you just want it in a different room. Ventilation, just in case you have any issues with that. I think the printer itself is fairly self-contained, so it's easy to manage in that. But I would still consider keeping it in a fairly open space, right? No, don't put it in a closet. I've seen some people with older replicators that they put them in a closet. That might be better for replicators or for printers that don't have a heated chamber, because you have to control, or you want to control as much as possible the draft or the draft or the currents in the room. So I think that don't put it in a very tight space. A living room works fine. A room works fine. Um, then also consider, again, make sure that your work surface is very stable, because the printer will be rocking back and forth, and the printer itself won't have an issue with it, right? But you'll hear the table bouncing around, and that's always adds to the noise levels. Additional considerations, material storage. So in this case, I actually have, I'll lower the webcam here. I have Wally here, but I also have just that little corner space where I keep the boxes of material. You don't need that much. The filament itself is probably about 25 centimeters, so maybe 10 inches in diameter for the spool. So having a place where you will store the material, that's also important. Where will you store the prints? As you create all of these prints, it's kind of easy for them to scale up, especially if you're doing your own studio or at home. Where will you keep those? If you want to authenticate external users, which is another great thing about Method, right? That you can actually invite other people. So if you're working with somebody else in your team, they can send remotely prints to the printer. And I can actually show you real quick how does that look like on MakerBot Print. So here I have that same tire that I showed you guys just a second ago, and I'm connected to the printer. So this is my Xbot. And the cool thing about being connected to the printer is that you can actually see what's happening in the printer, right? And if I put my hand in there, whoa, it's fairly fast. It's incredibly fast for that, actually. You can see how direct the connection is with the printer itself. So no, this isn't, it's not only to see what's happening with the printer, but also to be able to remote in and send prints directly to the printer, right? In another time, I'll do a rundown of my preferred settings, what do I use, how do I slice. So this is just a quick um, snapshot of our MakerBot print interface. This is how the file looks once it's sliced. So it'll show those two colors to represent the support material, which is the yellow or orange color, and the green material, which is going to be our material, right? Our model material. But it's the main reason for me showing that is because it's great to be able to also have somebody else connect to the printer. So let's say that somebody in the team is working on a separate component. They can send that component over, whether the printer is at the shop, at the lab, or at your house. It doesn't really matter. They're just remoting in, sending the printer from remotely, checking that the material is loaded correctly and everything, and just start printing, which is it's really great, right? Be able to transfer those materials around. Um, Let me jump back, not to MakerBot print, but to the deck again. So, there's a typo. That's not pricing options. Oh, lots of questions. So I'll skip through this because I really want to get the questions. The questions are the fun part. But overall, quick overview of Method and Method X. Method 60 degrees hot on the chamber. Method X 100 degrees, so it's really hot. And because of that, you can have a wider range of material, right? With Method, you have PLA, TUF, PG, PVA, nylon. And with Method X, you add ASA, ABS, SR30, and we are about to announce quite a few other materials. Which is why I would say like Method X is just a beast of a machine. It just has so many options, and it comes down to a technical element, right? It's like, can your printer get this hot? Not every printer can get this hot, and for most printers, when you're talking about these temperatures, you're probably talking about a $20,000 machine. So the price on the Method X is just super cool. We mentioned the labs expansion, right? That allows you to create, to have the printer as an open platform, right? Basically explore new applications, have additional materials like the flexible that I just showed. You can print with certain carbon fiber elements or carbon fiber reinforced, PETG, ESD, polycarbonate. It's a really, really nifty thing to have. And finally, here's where this is correct, the pricing and the offer. So right now they are running, I said that it was kind of nuts when I first heard about it, but they're running a 30% discount on both Method and Method X. For that price, you guys, it's kind of crazy. I'm happy that I have one myself, but yeah, I would definitely, if you're interested, send out an email to hello@MakerBot or contact our sales team directly. It's a pretty damn good deal. For $3,000 to get started with the Method, well, 35, it's a great machine. I don't want to spend too much time on that. I'll just say it again. Right now, there's a 30% discount. Oh, and by the way, this is only available for the first 100 customers, which is yeah. I'm sorry, but it's still, if you can get it, it's a great deal. Trust me on that one. But I'll switch over hopefully to the Q&A. Yeah. So with that, I'll go back to my the little voice in my head. So again, Allison, thanks a lot for running the things behind the scene. And I've got Allison here in my earpiece, so she's asking me questions and letting me know when I'm speaking too much about something, getting too excited. But I'll get to the questions first. So how seamless is CAD integration with the Method platform? Is there a one-click printing from CAD? Yes. So we have depends on the software that you're using. Somebody's asking about Blender. I don't think we have a plugin yet for Blender, but for many others, you can actually download a plugin for SolidWorks, for Autodesk Fusion, for Onshape as well, right? And you can directly from the website, from the software itself, from the modeling software, you can export directly to the printer. It's great. It's actually super fast, and you can also import any sort of native files. We have like 25 supported native files. The standard STL, of course, you can import. Blender, you can import Rhino. It's really flexible. How do I choose my printer? Well, I would say it depends. I think one of the great things about Method is that it's a really straightforward platform. The material itself is, quite literally solid, right? It's spools of filament. If you're talking about different systems, whether that be SLA or versus SDM, uh, in a small studio, in a small apartment, I really would not want to have an SLA printer just because the resin is kind of it's great for certain applications, but it can be a pain to manage, right? It's the resin in tight spaces and getting rid of it. In Method's case, all that you get is a rigid plastic element and then the dissolved supports, and that's it. So that's pretty straightforward. Regarding MakerBot specific printers, we have quite a few. Specifically, the professional ones are Method and Method X. It depends on what you want to print. So with Method, you have I wouldn't say limited, but it's a smaller range of materials. You can still access labs, right? So labs and that side loading and external mounting and using other materials, that's accessible for both Method and Method X. But Method won't have as big capabilities as Method X does, right? Method X really gets hot. It's capable of managing much more technical materials. So it depends on the materials that you want to use. Specifically for this SEPS material, you can use it in either Method or Method X. Doesn't really matter. The labs actually gives you practically unlimited possibilities with that. Does the Method X or Method print in TPU? So TPU is very similar to SEPS actually. I think that they've run a few tests on the site. If you're using the Labs extruder, you can 100% try it. I've seen, fairly good results with it. But after playing with the SEPS thing, I am not sure what the specific technical differences between both of them, to be honest, TPU and SEPS is. But we have printed in TPU with the Labs extruder. You can 100% do that. In this case, I'm using just SEPS, and it's been great. Do MakerBot printers have cloud sharing, or do I have to use a USB? Do I have to use a USB to place a file from the printer to develop for the printer to develop? So the answer is yes. You can do both. It has the cloud services, as I showed. You can send it directly through the printer. Through the computer, connecting to the printer, super easy. You can also use just regular USB. You can also connect directly via USB to the USB wire to the printer. So there's many options. I would say um, I like the USB one. Maybe I'm just old school. But with the wireless connection, you can actually see, how the printer is doing. If I'm not around, then the wireless is much better because I can actually track the printing progress from my phone, which is kind of interesting too. Can I upgrade firmware directly over with Wi-Fi connection? Yes, you can. So the printer itself, once it's connected to Wi-Fi, you can just download firmware through it and super easy. As I said it at the beginning, you can do it either with a USB stick or via the Wi-Fi. It takes about, I don't know, 10 minutes maybe. So just, and by the way, if your printer is connected, every time that we release a new update, it'll prompt the printer and you'll get a notification saying, hey, there's some new features you might want to test out. Would you like to download the latest firmware? And you can just do that. Does it integrate with Stratasys GrabCAD? Well, with GrabCAD, you can actually download STLs, right? So yeah, you can download the STL files and there's no problem with that. Stratasys is our partner company, so we do keep a tight connection with that. And if you're talking about the GrabCAD slicer, I'm not sure I've used the GrabCAD slicer lately. I'm pretty sure they would, but otherwise, our slicer is also free, open for anybody. So you can just go to our website and download it. What's the method build volume? It's going to be roughly about 7 cubic inches. So I don't have, I haven't printed something really big so far. This is the biggest one. This is about, it's about 7 by 4 by 3 inches maybe. But yeah, it's about 7 cubic inches. For the technical specifications, you can go to the site, makerbot.com/method, and you will have all of the technical rundown with it. Do I have to worry about smells and odors? Not really. So I have it by the window just in case that it smells a little bit. But I haven't really experienced it that much, especially because it's sort of contained, right? So it's not as I remember when printing with my replicator, it always smells like pancakes sort of, or that's the smell that I got, or corn syrup. I don't know how to describe it, but here it's fairly mild, so not really. Can I track print analytics? If you mean by that like success rate and how many prints have you done so far, there is a tracking inside of the printer that you can use. We are working on developing a software to do specifically that, but right now I don't. Right, and then on My MakerBot, you can also so there's a dedicated service on your account from MakerBot that's called mymakerbot.com that will allow you to do a more in-depth rundown of the printer itself, like lifetime and stuff. We are expanding that currently. How many cameras does it have? It has one camera. I don't think you need more than one camera, but it has one camera. It's located right here in the front of the printer, and quite a bit of sensors. Right, it has humidity sensors on the drawers. So the drawers are not just drawers, right? I made it sound like it's just a drawer, but it has a humidity sensor inside. It'll let you know if the material is actually got too high a humidity level. It has filament detection sensor. It has temperature sensor. It has filament presence switches all over the place, both in the drawer and in the extruder. So yeah, it's quite a robust machine. Would you consider MakerBot printers friendly for someone who has never owned a 3D printer before? Yes. Well, the cool thing about this, and I said it, I said that this is a beast of a machine. It's crazy. It's a beast in that it has so many impressive features, but at the same time, it's so easy to use, right? It has a freaking touchscreen. So you saw it, the video, right? The quick time lapse. It takes you 30 minutes, 40 minutes to set it up. It's kind of amazing. So yeah, it's one of our key goals as a company. I think it's that user experience and the ease of use. So 100%. It's super easy to use, great product, great machine, and just a lot of fun. Um, once owned, once printed, are PVA and nylon still affected by humidity? Yes. So PVA, okay, PVA you will only use as a support material, right? That means once the print is done, you will want to dissolve it, like quite literally expose it to water in water, so that it dissolves away. You saw that photo maybe at the beginning of the deck where there was a lot of white elements here. That was SR30, not PVA. But PVA, the goal is for you to dissolve it once the print is completed. With nylon, it's yes, if you're planning on putting like a printed part underwater or something, it can degrade nylon. So I would say there are other materials that are less prone and less sensitive to humidity, like ASA. It's great for outdoors. If you're thinking about something that needs to be exposed, ASA is a better material for that. After printed, does humidity reduce strength or cause dimensional changes for close tolerance parts? As I said, it depends on the material, right? If you're printing with ASA, it's going to be um, much less prone to that. PETG or PETG, that's also great for that. I would say it depends on the material, right? Some materials, yes, if you put them, leave them outside in the sun, they will probably deform a little bit. Some others don't. It depends on the material and the application that you're looking for. Material side loading, right? So you can side load this actually. Let me take this out, show you guys how it looks like. There's a side port on the machine, and we actually developed. This is one of our designers, Quincy Kwang, who developed the side load mount. You can print this. This was actually printed on the machine itself, right? Just a mount on the side and it PTFE tube that allows you to route the filament. But yeah, you can 100% side load using our labs extruder, and that basically allows you to print with any material that you want. Lots of questions about materials as I see. I think, there's, I just showed you guys like, a list of 8, and I probably have here like 20 of them. So just a follow up of just materials I think would be great, whether, I can show you some parts. If you have specific questions, do send them over at hello@MakerBot. Why did I use polycarbonate for this versus ABS on this, and why would I use SEPs, and what's, kind of like the sensitivity that they have to humidity and those sort of levels. We are also doing every Wednesday morning, every Wednesday at 11, we're doing what we call MakerBot chats. So it's kind of an informal platform where you guys can ask more questions like that. If you want to tune in, next Wednesday at 11, I'll be here as well in my living room, super happy. Uh, but yeah, tune into that, and we can 100% discuss more in detail specific materials. How much time does it take to build 10 by 10 by 10? Okay, so it depends on the infill. I would say like, this is 10 by 10 by 10 centimeters. That's about 4 inches cubed. Um, that's going to take closely, I don't know, maybe 15 hours. About that. It depends on the infill, right? If you want a solid piece versus a hollow piece, it's going to change a lot. Even in these tires, right? Right now, we have been printing, you guys may have heard, we are supporting the local effort to print face shields. So for example, this face shield that we're working with Columbia Hospital here in New York, given the current state of events, we're helping in our office to print a lot of these face shields. And these themselves, they take about 40 minutes for each one of the face shields, right? So it depends on the geometry itself. It depends on the geometry, the specifications. Yeah. how can I estimate print time for a MakerBot method? That's MakerBot print, right? If you go to MakerBot print, once you slice is basically the process that happens when our software converts your CAD file to the instructions of the printer. That will give you an estimate of both the time and the material usage. So could you yeah. Oh, yeah. Also, I forgot to mention that MakerBot Print is free, right? So you can try it out for sure. You can use, download it, play with it a little bit, import some files to it, see what are the parameters that you can change. You don't need to have a printer to use it. Well, yes, to print, but not to actually play around and tinker with the settings. There's a lot of different changes that you can make on method specifically, whether that be adjusting the temperature in the chamber, adjusting the temperature in the extruder, the flow rate, the cool rate. It's impressive what you can do. Webcast focusing on how to start a small business on doing 3D printing at home. Oh, okay, that's interesting. So doing a webcast on 3D printing at home as a small business, I think that would be interesting too. I remember when I got my first printer, it was like my first maker was probably like 7 years ago. I got a replicator too, and I probably paid for that printer in the first 3 months that I was actually just lending it to friends. I was close to the architecture community and design community, and it's an interesting side thing. How do you get Method X to send a message when that's finished? You can track it on the phone, as I said before. You can download the app and you can see like when it's finished. You can also see the process on MakerBot Print remotely, and just have a check mark once it's done. If I purchase a method and feel that Method X winds up better for my application because of speed, for example, I don't. So Method and Method X, whether there's a difference between them in speed, not really. The systems are similar in that regard. The main difference is going to be the materials that you can access because of the temperatures that it can achieve, right? Method X, sorry, can get so much hotter, almost twice as hot as regular method. So yeah. And then, great one. I think, what's my favorite material currently? It's, of course, these flexible CEFs. I already printed, I went a little bit crazy and I printed 4 of these wheels. I may or may not be thinking about doing a full-on little boogie, especially now with the weekend coming along and a lot of time in my hands to spend inside. But yeah, the flexible material, it's super exciting. It's kind of like interesting to think about what you could do, whether simulating overmolds, simulating pipes. But I'll play with it a little bit more and let you guys know for sure in the future. And with that, I think we've covered most of it. I think thank you guys again for joining today. It's been my pleasure to have you here in my living room again. We'll be doing this more often. As I said, there's MakerBot chats happening every Wednesday at 11 Eastern Time. Same location, my living room. If you have any questions, do reach out, hello@makerbot.com. We also keep track of Instagram, so follow us at Instagram and Twitter. You can reach out to us directly, so at MakerBot, both in Instagram and in Twitter. And let us know, if you have any suggestions on topics, if you want to learn more about specific materials, if you have questions about the printers, and we'll answer those. Seriously, check that promo out. It's freaking crazy. But anyways, that's my plug there. Get a method. It's a pretty fun machine, especially to spend this cute time with. But anyways, thanks a lot for watching. I'll see you next time, and thank you. Thanks again.